Hello viewers, you're welcome back to my channel. This is the fourth and last part of the video lessons on circle geometry. And in this video lesson, we are going to look at 4 more theorems in addition to the 6 theorems we've looked at in the previous video lessons. And thereafter, we'll solve some practice questions to help us retain our knowledge on circle geometry. So we'll begin this video lesson by looking at the 7th theorem. So we'll begin with theorem 7, which happens to be the first theorem in this video lesson. And theorem 7 states that the opposite angles of a cyclic quadrilateral are supplementary. Now, looking at this theorem, there are some key statements which are opposite angles, then we have cyclic quadrilateral, and lastly, we have supplementary. Now, when we say opposite angle, what do we mean? It simply means angles that are facing each other. So they are simply angles that are facing each other. Then moving on, we have what we call cyclic quadrilateral. But we must understand what a quadrilateral is before we understand what a cyclic quadrilateral means. Now, the word quadri just simply means 4. Then lateral simply means side. So in essence, a quadrilateral is a shape that has 4 sides and also 4 angles, because if a shape has n sides, it will definitely have n angles. So if the shape has 10 sides, it must have 10 angles. So in mathematics, what are good examples of quadrilaterals? We have square, which are familiar examples of quadrilaterals. We have rectangle. We have what we call a rhombus. We have a kite. We have a parallelogram, so on and so forth. So we have those good examples of parallelogram. So basically, a parallelogram or a rhombus or a rectangle or a square just have 4 sides and by inclusion 4 angles and the other examples. Then we move on to look at what we call a cyclic. Cyclic just simply means in a circular form. So in essence, a cyclic quadrilateral is simply a quadrilateral that is within a circle. And what can make us to call that in a cyclic quadrilateral? It vertex. Vertex just simply means where 2 edges meet. This sharp point is a vertex. 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 So now a cyclic quadrilateral is simply a quadrilateral in which the vertex touches the circumference. You know the circumference is this part that goes round the circle. So for we to classify a quadrilateral as a cyclic quadrilateral, its vertex, the 4 vertex should touch the circumference. Then if I have something like this, let's say we have something like this, like this, like this, and then like this. Now looking at this shape, it has 4 sides, side 1, side 2, side 3, and then side 4. But not all the vertex. This is a vertex that does not touch circumference. This vertex does not touch circumference. This vertex do, and this vertex do touch the circumference. But in this case, because all 4 vertex do not touch the circumference, we cannot call this a cyclic quadrilateral. So in essence, cyclic quadrilateral are just quadrilaterals in which the vertex, that's the 4 vertex, touches the circumference. Now moving on to the theorem. Theorem simply says that opposite angles, like we said, opposite angles they face each other, of a cyclic quadrilateral are supplementary. Now in mathematics, we say angles are supplementary when they add up to give you 180 degree. For example, I can say 120 and 60 degree are supplementary because the singular reason is that when I add them up, it will definitely give us 180 degree. I can as well say 110 degree and 70 degree are also supplementary. The singular reason is that when I add them up, it will give us 180 degree. So in essence, what is this term telling us? It's telling us that opposite angles. So in this case, A is opposite to D. So it simply means that A plus D is equal to 180 degree. So also I have B on this side facing C. So again, we can therefore infer that B plus C will give us 180 degree. So this is basically what theorem 7 is telling us. And also, one thing to just prove this is that whenever you add up all the angles in any quadrilateral, no matter how it is drawn, either a square, rectangle, rhombus, parallelogram, kite, or a trapezium, when you add up all the angles, it should give you 360 degrees. So in essence, sum of angles in a quadrilateral is equal to 360 degrees. 360 degrees. So definitely, if you add 180 here plus 180 from the opposite sides, it will give you 360 degrees. But basically, this term tells us that opposite angles of a cyclic quadrilateral are supplementary. So if I know that one side is 90 degree, definitely the other side should be 90 degree. Why? Because they must both add up to give us 180 degree. So theorem 8 states that the straight line which is drawn at right angle to a radius of a circle at its point of contact is a tangent to the circle. Now, what was this straight line? This is straight line we are talking about, AB. And we know that any straight line that is outside the circle that touches the circumference, we rightly call that line a tangent. But now let's go back to this theorem. So this theorem states that we have a straight line which is drawn at right angle. You know, a right angle simply means 90 degree. So which is drawn at right angle to the radius of a circle. So this is a straight line, this line outside, which we call the tangent. And this line is drawn at right angle, this is the right angle here, to this radius. The radius runs from the center to the circumference. Now this straight line, which is drawn at right angle to the radius of a circle at its point of contact, so this is where it meets here, is a tangent. So in essence, this just further defines tangent for us. And we said that tangent in our previous video lesson is an external line, external because it is outside the circle, an external line which touches any point of the circumference, which touches any point on the circumference. So this is simply a tangent. So basically, if we have an external line but it does not touch any point of the circumference, we cannot call that a tangent. So if we have something like this, because this line does not touch any point, we can't call this a tangent, but a tangent must touch the circumference and it's always at a right angle to the radius at their point of contact. So in theorem 9, which is our third theorem in this video lesson, states that the angle between a tangent, already we looked at a tangent in the previous theorem, which is theorem 8. Now the angle between a tangent and a chord, so we have a tangent and then we have a chord, that angle between both of them is equal to the angle subtended in a way formed by the chord in the alternate segment. So now there are some key words we are going to pick from this theorem, which is the angle between the tangent and the chord, and then this other word, alternate. Alternate just simply means the opposite side. So now we have a tangent. I will mark this as this is the tangent, this external line. Then we have a chord. Now we know what a chord is. A chord is a line that runs from one point of the circumference to another point, but it does not pass through the center. So that's what a chord is. Now the angle between this tangent and this chord, let's say this is theta. The angle between this chord and this tangent is equal to the angle that will be formed. That's what subtended mean by that same chord. So this is the same chord here, this chord. So let's say this is AB. That's our chord. So the angle between this chord and this tangent will also be the same angle that this chord will form in the alternate. Alternate means the opposite. Now you know this is one segment. So this is segment. Let's say segment 1. Segment 1. Then we have another segment. Let's say segment 2. Segment 2. So this angle was formed in segment 1. This angle will also be equal to the angle that we are going to have in this other segment, which is segment 2. So now when this chord forms an angle, so let's say something like this to here and then to that point of the chord. So this angle here will also be theta. So if this angle here is 60 degree, this angle formed by the chord will also be 60 degree. Or let's say let's come to our second diagram. We have this chord. So this is our chord right here. And then we have the tangent, which is the external line. So now the angle between the chord and this tangent is what? Y. So this angle will be equal to this angle formed in this other segment. So this will also be Y. So this is one segment, this is the other segment, because this line, which is the chord, divide that circle to two segments. And we call the smaller one a minor segment and bigger one a major segment. So in essence, the angle between the tangent and the chord will be equals to the angle subtended by the chord in the other segment. That's what the alternate here means. Not in that same segment, but in the other side of the chord. So in our last theorem, which is theorem 10 in this video series, says that if two tangents are drawn to a circle from a given point, so we'll begin by using our diagram because it's a very lengthy theorem. So we have two tangents drawn from a common point. So this is our common point P. So we have this tangent. Let's say this is AP. and then this is BP. So we have one target up, AP and BP. So both of them are drawn from a common point, which is this point outside. Now, there are three things that are true about this tangent. Number one is that the tangents are equal in length where they meet the circle. So at this point where they meet the circle, this point of contact, if you measure from here to here, let's say that from here to here is 5 centimeter. From where they meet the circle to their common point is 5 centimeter. That means that from here also, where it meet the circle to here will also be 5 centimeter. So this first part says that the tangents are equal in length actually at their point of contact with the circle. Secondly, the next thing says that the angle between the tangent is bisected by a line. You know what bisect means? Bisect means to divide to two parts, to divide into two parts. Like we said, bi means to sect means divide. So to divide into two parts. So now the angle between the tangent is bisected by a line joining the center of the circle. Now this is the center of the circle and that external point. So if we have a line, so let's say we have an angle here. Let's say, for example, 60 degrees, for example. And then a line passes from here, from this center to this external point rather. So this is external point, not a line. So that's the external point. So when we take a line from the center to that external point, that line is going to bisect or divide that angle into two halves. So if this is 60, the full angle, then half will be 30, and that part will also be 30 degrees. So when we have a line that is drawn from the center to that point, it's going to divide the angle between the tangents. Lastly, the tangent subtend the same angle at the center. Now this is the tangent AP, that's from here A to P. Now the angle formed at this center will also be equal to the angle formed by this other tangent. So if here is 70 degrees, then here will also be 70 degrees. Because in real this line just divides this angle we have at this point. So in essence, when you have two tangents that are drawn from the same point, there are three equal things about that particular tangent, either at the center or at the external point. Number one is that the tangents are equal in length wherever from where they touch the circle to the external point. Thirdly, or secondly rather, the angle between the tangents can be bisected by a line that joins the center to that external point. And lastly, the angle or the tangent rather form the same angle at the center of the circle. In this section of this video lesson, we are going to solve some practice questions to help us understand the theorems we have looked at so far in this video lesson. So I urge you to pause the video lesson at the beginning of every question and then try to solve the questions before coming back for a detailed answer. So we'll begin this video lesson by taking question 1. And the instruction says, find the size of the angles marked with letters. Now, when you look at the first question, this question clearly takes us to cyclic quadrilateral. And recall that in a cyclic quadrilateral, the opposite angles are supplementary. So the key takeaway is that the opposite angles are supplementary. And again, we said that supplementary angles are angles that add up to give us 180 degrees. So when two angles add up to give us 180 degrees, we can clearly see that they are supplementary. Now again, this is a cyclic quadrilateral. Like we said, this vertex should touch the circumference. So we can clearly go ahead and use our knowledge on cyclic quadrilateral to attempt this question. So looking at this question, angle A is opposite to angle C. So we can therefore say that angle A plus angle C, since they are supplementary, it should add up to give us 180 degrees. Now angle A is X, which we have here. Then angle C is 120 degrees. Is equal to 180 degrees. So in mathematics, we are simply going to collect like terms. So this becomes 180. Then when 120 is taken to the other side, plus 120, it's going to be a negative 120. So therefore, 180 minus 120 is going to give us 60 degrees. So X is 60 degrees. Now looking at angle B and angle D, they are opposite to each other. So I therefore have it that angle B plus angle D is equal to 180 degrees. Now angle B is 88 degrees plus this y, which we don't know, and then it is equal to 180 degrees. So again, we'll collect like terms. So y is going to be 180 degree minus 88 degree, because when 88 comes to the other side of the equation, it's going to be negative 88. So when we subtract 180 minus 88, our answer is going to be 92 degrees. So the final answer to this question is 92 degree for angle y and then 60 degree for angle x. So move to the second question. So in our second question, we have this diagram here where we know that O is the center of the circle. We have an external point, let's say P, from where both tangent, this tangent, so let's say this T1 tangent 1 and then this tangent 2. So remember that when we looked at concept of same tangent that are drawn from the same point, which happens to be our last theorem, we said that the first thing is that when they are tangents that are drawn from the same point, they are both equal in length. That's fine. So therefore, the length of T1 should be equal to the length of T2. And also, we say that when there's a line that is drawn from the center to bisect that angle, both angles are equal, and that's correct. And then lastly, the tangent, this tangent meets the radius, this is the radius, at what? Angle 90 degree. So without being told, we ought to know that the angle here is 90 degree. So again, this is a radius drawn down here, and then this is our tangent T2. The angle between them is 90 degree as well. So in your exam, you won't be told, but they expect you to know that the angle between a tangent and a radius at their point of contact is 90 degree. So you have to keep your theorems in mind because they will help you a lot in solving questions. Now let's come back to this triangle up here. So in this triangle, I will just take the borders. So we have something like this triangle. We are going to use this triangle to get M, which is the unknown angle. So remember that the sum of angles in a triangle. So we have something like this. We have something like this. Then we have something like this. So this is 25. This is M. And then this is 90 degree. So remember that the sum of angles in a triangle, is equal to 180 degrees. Sum of angles in a triangle is equal to 180 degree. So with that, we can solve to 180 degree. So in this triangle, we have 25 degree, then we have 90 degree, then we have M, which we are looking for, and the sum should give us 180 degrees. Now, 25 degree plus 90 degree will give us 115 degree plus M is equal to 180 degree. Then we'll collect like term. So M is simply going to be 180 degree minus 115 degree. So when we subtract that, we are going to end up getting 65 degrees. So the unknown angle M is 65 degrees. So in our third question, we have this diagram here. Now looking at this question, we have a tangent, that's the external line. Then we have this chord, this line here is the chord. We have the chord. Now recall that in one of the theorems, we said that the angle between a tangent and a chord, that's this angle here, is equal to the angle in the alternate segment. Now, if you look at the alternate segment, the angle formed by this chord, this is the chord, this is the chord. If you trace it, you trace it up, trace this up, this is the angle formed by the chord. So the angle formed by this chord will also be 64 degrees because the angle said, or the theorem rather said that the angle between the tangent and the chord is equal to the angle formed by the chord in the other segment. That is why, without being told, this angle here is 64 degrees. Now, when you have done that, you now have a triangle. So let me mark a triangle. Let's say A, B, C. So we have a triangle. And again, sum of angles in a triangle is equal to 180 degrees. So sum of angles in a triangle again is equal to 180 degrees. So in that triangle, we have 64 degrees. Then we have 48 degrees at B. Then we have X, which we are looking for at C. And this should add up to 180 degrees. Now, 64 plus 48 is equal to 112 degrees plus X is equal to 180 degrees. So we are simply going to collect like terms, and when we do that, we are going to have 180 degree minus 112, that's 112 degree. So when we subtract, this should give us 68 degrees. So the value of x is 68 degree. So in our last question, we have this diagram here. We have a common point where two tangents are drawn, and that common point is T. We have A, we have C, and then we have B. So we are meant to look for X and then Y. Now, what I can simply do is just to introduce a line from this common point. So I'll introduce a line from this common point to O. Now, when I introduce that line, I have a triangle. This triangle A, T, O. So I have a triangle. So with this line passing through, I'm going to divide 62 because 62 was the entire angle. But half of 62 will be 31 degree. So now I'm going to look for this angle. Again, this is a tangent. This point is a tangent. This is a radius. An angle between a tangent and a radius is also 90 degree. So I can look for this part. So let's take this part to be M. So in that part, we have a triangle, and recall that sum of angles in a triangle is equal to 180 degree. So 90 plus 31 plus M is equal to 180 degree. And 90 plus 31 will give us 121 degree. Plus M rather is equal to 180 degree. Now M is equal to 180 minus 121. So therefore, when you subtract, you are going to have 59 degree. So therefore, one part is 59. So we have this to be 59. Recall that this side will also be equal to this other angle, which is also 59 degree. So X will be a combination of 59 and 59. So X will be equals to 59 plus 59 degree. And when you add this up, we are going to end up getting 118 degree. So the angle at the center X is 118 degree. Now, if you remember one of the theorems we looked at in the earlier video lessons, we said angle at the center is twice the angle at the circumference. Angle at the center is 2 times the angle at the circumference. Angle at the circumference. So now, if you look at O, which is the unknown angle, which was X, that angle is the angle at the center, which is 118 degree. So it's going to be 2 times of this angle we are looking at the circumference. This is the angle at the circumference, Y. So therefore, we are going to divide outside by 2. And when we divide outside by 2, we now have Y to be equal to 118 over 2. And this should give us 59 degree. So therefore, angle X, which was one of the angle we are looking for, is 118, and then angle Y is 59 degree. So viewers, I hope you learned something from this video lesson. Don't forget to give this video lesson a thumbs up, and also do it to share this video lesson to your friends so that we can all learn together. If you have any question, comment, or suggestion, do it to leave them in the comment section beneath this video lesson. And also, if you haven't subscribed to this channel, do it to click on the subscription icon and turn on the notification bell so that whenever I release any new video, you always get notified. Till you get to see my next video, do have a wonderful time.